I like learning about arithmetic series and sequences. And so I pretty much have 2 more formulas for you guys to remember. But the first formula is really easy to remember because we're going to kind of have it upon it, okay? I have a story for you. Gauss. He's an early mathematician. But before he was this brilliant mathematician who proved a ton of things, like he's one that came up with how to solve systems using row operations with matrices. Those of you who get to move into 1010 and 1050, I might see you next year. And we will be doing matrices in 1050. And we'll be teaching you guys how to solve a system. And when you solve a system, you can use elimination, but an organized way to use elimination is to put it to matrices. And Gaussian is one of the mathematicians. There's another mathematician with last name Jordan, but Gauss came up with a way to solve matrices. He also early on was a really, really, really hard student. So I want you to imagine a really hard student, and there's been reports both ways, and I actually forgot to confirm it today. So I thought he was in like 8th grade when this went down, and then I could have sworn when I had a conversation with another teacher, they were like, no, he was like in 5th grade. So when he was a 5th or 8th grader, I know that's a big difference, but I still think this is stuff for anyone. So I need you guys to have notes out to do this next part. The teacher was kind of fed up with him, and I think it's because back then they didn't know he was gifted. He's bored, he's pretty gifted. And also back then things were harder. They were still discovering so many things. And they didn't have easy ways to do math, they didn't have theorems, they didn't have anybody who proved stuff. And so I can't imagine being born at that time and being so interested in why does this work out the way that it does? And just imagine the problem solving skills that you develop to try to figure things out. So with that said, the teacher's and this could be just a little legend or a myth, but the teachers, they claim that they said to him, you know what, stop bugging me. I need you, and without any tools, I need you to go and just add up all the numbers from 1 to 100. Just to get them to stop annoying other students, get them in the corner. She stuck them in the corner and said, go figure this out. Well, Gauss actually came back within 3 minutes and had the total. And this is without a calculator, you guys. It's because he kind of came up with some interesting pattern he noticed. Okay? With that being said, I want to pause the video for a second and I want you to try to discuss in a couple of your groups, what do you notice and how can we make this easier? Pretend we don't have a calculator, to just go put in 100 values. You can get lost. Don't you think along the way? 1, that's 2, that's 3, that's 4. Take a moment and let's see if you guys could come up with it. Someone in the 5th period did come up with a rule. It was slightly different, but it was actually on track, and he figured out the rule himself. So it's kind of interesting. Let's see if we can too. I'm going to make you feel a little sense of competition there. So while I'm doing that, you guys are going to hand out work. Is there anybody who was able to come up with any sort of rule or pattern you noticed? Anything? Go ahead.
I noticed that in the pattern here that I'll go with 100 for the max, and then I went from 199 that equals to 100. So just continue through that, just back and forth, to see 100, 100, 100, 100, until you get to 50-50. Then you count how many hundreds those are, and then you just do 100 times 100, and you get that much.
You're super close. So he noticed the pattern. It's almost like you cut off this. So you're kind of similar to the student earlier. They essentially noticed something else. Well, theirs was slightly different, but they're all very similar. So to kind of say what Ty was noticing, 1 and 99 make 100. 2 and 98 make 100. And so what he's saying is that's how many times I would add 100. Plus, I can't forget about this first 100. And it's kind of tricky, though, how you just tell somebody, just drop off the front one. So I do have a little better understanding, but you're on the right track. Yep. So he did do this. Gauss did come up with this little rule, realizing, I'm adding the same numbers over and over and over again. The person in 5th period noticed for any series of numbers, he just used for easy numbers the first 5. He took the ending term and times it by the median. So there's 5 terms is what he's saying. So this is 5 terms. That's for this specific theorem. And then he times it by the median or the middle, which was 3, and it's 15, and that's what really adding them up really is. So then he tried with a bunch of them. He tried with 1 to 50, and so he's kind of on the right track a little bit, like with with using the middle and how many terms there are. This will have to do with how many terms in a second, okay? So we'll kind of talk about that number in a second. So, and did anybody else come up with something a little bit differently with like the pattern that you kind of noticed? So he's right on track. I'm actually going to kind of fix a couple things though. Instead of just dropping the front one, if you still do what we just said, 101. 101.
Okay.
It works, even if you don't drop 100, okay? So we essentially are adding 101. How many times will this take place? About 50 times, right? Well, yeah. Because we're going to be getting right in the middle to like 51, 50, right? So we are going to be technically, to find the sum of this sequence, taking the sum of these 100 terms, and we are going to be taking the numbers that they add up to and timesing them together 50 times. Now, that 50, how does that relate to the number of terms we have? I'm going to kind of go to this rule just a little bit better. To add this together, and by the way, this is arithmetic, isn't it? Did you guys all notice that this was an arithmetic sequence that she gave Gauss? This was arithmetic, and what was our common difference? A 1. Okay, so this is arithmetic. And so let's kind of put this theorem together a little bit better, more generic. So what did the 1 and the 100, or the 2 and the 2, whatever, what did the 1 and the 100 represent? What's 1? Our what term? Our first term. What's 100? Our what term? It's our nth term. It's our last term. Or you could have done second and second to last, or whatever. It really doesn't matter. So if we take our first and our last term, and then what was the 50? However many terms there were what though? Cut in half. So if there were n terms, the 50 was us taking the number of terms and cutting it in half. Well, you guys, this is the sum of an arithmetic sequence. And we just pretty much learned that. Now, I'm going to be posting this on the next page, so if you're not going to write it down quite yet, you do not have to. But I want you guys to kind of see how this works a little bit. I want you guys to take a moment and use this little property we just kind of came up with. And let's not do it where it's just changing by 1 every time. Let's just try it on something else before we kind of just confirm that this is how it's going to work. Do you guys remember the toothpick activity that even though we didn't get to do the full activity, we kind of in theory were like, okay, 4, but then it'll be 7, but then it'll be 10, but then it'll be 13 toothpicks and so forth, right? Okay. Now, what if I want the sum of my first, so what is this communicating to you if I say this? Let's just refresh our memory on summation notation. What if I was saying this to you? And I have the rule for the sequence. Do you guys remember the rule for this being 3n plus 1? Do you guys remember that? Do you remember the rule for like the toothpicks being 3n plus 1? How many terms in this sequence am I asking you guys to add up, by the way? Let's just kind of recap what this means. Because you're going to be being asked stuff in so many different ways. And I want you to be comfortable if it's asked in summation, comfortable if it's asked as a list, like this, comfortable with anything, right? What am I asking you to do here?
Is it asking us to go to 12 starting at 1?
The 12th term, correct. Okay? Well, now that we have the formula, I want you to find the sum of my first 12 terms. How many terms? 12 over 2. What's my first term of my toothpick sequence? What's my first term of my toothpick sequence?
4.
Good. We don't know our what term though?
Five.
We don't know our last. Now pretend that was really far up, and I don't really want you guys to sit there and just count it out, okay? Let's just pretend. If I gave this sequence to you in summation notation, I would take the time to find a sub 12, correct? If I didn't give it to you with any rules, pretend this rule wasn't here, we also have the nth term formula. You guys, what's the nth term formula? If I don't know something, you guys are going to go back to your explicit formula for nth term. It's first term plus your common difference for n minus 1 times. You remember that? So you guys may be using this nth term formula over and over and over again whenever you're missing parts to fill in your nth term. We have to find it. Okay? So my first term was 4. What was this toothpick one's common difference? 3, right? And then I have to do that for 11 times. So 4 plus 33 puts me at what? 37? So I could have done it this way, or if I gave it to you in summation notation, I could have just plugged in 12 to this. I could have said 3 times 12 plus 1 also gives me 37. Okay? So do you guys think you're pretty equipped no matter which way we give you guys a series, but we ask you to find the sum of it? Do you think you could come up with these 3 things? You either need to know n, first term, last term, or you have to find it if you're missing any of those parts. Make sense, everybody? All right, just for practice, let's figure out how many toothpicks we had when we added all these toothpicks up together. This is us doing different piles, like 4, and then 7, and then 10, like doing different piles. It wasn't just adding 1 and 3, okay? So we would end up having 6 times what? What is that, 41? What do you guys get? How many toothpicks total if we had all these piles of 4 and then 7 and then 10? 246. Good job. So in a nutshell, you guys have 2 very important formulas to remember. Nth term formula for arithmetic, and then the sum of arithmetic. Okay? So I have this on the next slide, just a little bit more organized, and then I have a couple of problem-solving things, and then you guys will kind of just work through the rest of your homework. So remember, n over 2, first term, last term. If you're missing any parts, don't forget your explicit formula for nth terms. Have that somewhere in your notes, and I would have everything just kind of organized that these are your main formulas for arithmetic. So for instance, let's try one that we didn't already know the rule for, and let's just try one from beginning to end, okay? I just gave you a series and I asked for the sum of the first 150 terms. Or I could have given this to you in summation notation, and I could have had a 150 at the top of there, okay? So whatever way I ask you, this is what we're asking you to do. What would you do? So first I'd start off by writing sum and then a little 150, right? That's a good start. What do you know now from that formula?
Well, we know the sequence of the what I did is, if it isn't like negative or positive, first I tried out negative or positive, so I went 16 minus 5, and then did 27 minus 16.
Okay. You're realizing this is arithmetic, so you can use this formula, is essentially what you're saying to me, right? What are you saying to me, I guess?
Yeah.
Your common difference is what?
11.
Okay, sweet. So you found the common difference to be 11, therefore it's arithmetic. Good start. Okay, you should always do that first. Now what do you know? Now when we know we're finding the sum of an arithmetic, what do? Go to the sum formula. From the sum formula, right there, what do I know? What's n, you guys? We do know first term too. Let's start with n though. What's n? 150. Because I'm trying to find the sum of my first 150th terms. Okay, I also know what, Ty? You said it.
First term.
I do know my first term. What don't I know yet, though? I don't know my 150th term. So does that mean I just don't have enough information, can't be solved? Or do I know how to find a 150th term?
You use the other equation.
I use the explicit formula to find the nth term. So I go over here and I'm like, I need to find what a sub 150 is. And I don't have an explicit formula like 3n plus 1, but I do know this. I do know that when I want to try to find a certain term in my sequence, I put my first term and I add my common difference, which is what Ty noticed. How many times?
450.
It'd be 150 minus what?
1.
150 minus 1 times. Does anybody mind helping me find what this 150th term is? You said what? 1644. Perfect. So since this end of the term is 1644, it goes right here in my sum formula. It's just about formulas. And now that we know where the formulas came from, they're just way easier, I think, to kind of memorize and kind of know, right? So let's go ahead and do the math. It looks like it's going to be 75 times like 1649. All right. What's it going to be? Very good. You did it. So are we pretty comfortable as long as you can find a way to find n? First term, last term, you can find the sum of the sequence. All right, what's this one? I just found out that Micah has a job. Micah told me about this job the other day. He works for the Jazz. And the Jazz is like, you're in charge of putting shirts on this section of seats. Have you guys ever been to a game or watched on TV where you'll notice the whole section has orange, the whole section has white, the whole section has yellow? Have you guys ever seen it? And when people show up and it's a t-shirt night, they'll have like a shirt draped over their seat, or they'll be handed as they're walking in. And have you guys ever noticed on the first half they're like waving those little clappers or the name things in front of the people shooting, right? The opposing team. And then at halftime, when people come back from the dinners or whatever, the other section is handed things. Okay. So anyway, Micah has a new job, and he was asked to take yellow shirts to his section. His section is kind of on a bend, and so the first row in that section has like 30 seats, but because it's kind of on a bend, these ones have 30 seats, and in order for these next ones to be able to handle another bend, they actually have one extra seat. And it continues, and he needs to know how many shirts to grab. Obviously, they would know how many shirts to tell him, but let's pretend Micah doesn't know.
He wasn't listening to
He was
the
listening.
presentation.
I know, he was listening.
Oh,
So we're trying to find the sum of how many numbers in the sequence. The sequence is 30. What's on the next row? 31 seats. What's on the next row? So our common difference is easy to see that it's what? 1, which I should have picked something better. And then how many terms are we going to be adding together so he knows how many shirts to pick up? Okay, so that's going to go where? What goes right here? 20 over what? Very good. What goes right here? First term.
So it would be 30.
Good. And then I need my last term. Do I have my last term?
Not yet.
Not yet. We need to know how many shirts Micah will have to get for that last row to be able to do this formula. So I don't have enough information to use just this. So we're going to jump to the side and do a little side thought. And what can I do now? I want to find what term in this little sequence here? I want to find the 20th term. How do I find my 20th term of arithmetic? First term plus my common difference, right? Because it's n, or a sub n, plus your common difference, n minus 1 times, right? So we are going to do that for 19 more steps in the sequence. Perfect. How many shirts is that in the top row? Just 49 in the top row. Okay? So we get to place 49 right here. And now Micah can calculate how many shirts he's supposed to grab, because they kind of like just leave him on his own. They're like, good luck, make sure you fill up that section, blah, blah, blah. Okay, how many shirts is he going to have to somehow put in a cart or carry? 790 just for that section. Does that make sense how series kind of work though? And that's like a real world example that's kind of fun to kind of see. Okay? That is for arithmetic. Do you guys feel pretty confident if I move on to geometric? All right, I don't have a fun story or a mathematician, and this one's going to look a little more daunting, but don't worry. Find the sum of the first n terms of a geometric series. This is the formula for a finite series, and what I mean by finite is there is an ending term. There are infinite series where there isn't an ending term, and ones we have decided to not teach that to you. So something that doesn't end, you wouldn't be able to find its sum, but something that does, like decay, it approaches 0, so you can find a sum even if we don't know the last term. We have gone away from teaching you that. So everything you're going to do is a finite series. I actually have to change the quiz a little bit, then I just realized because of that. But with that being said, that's why we use the word finite, okay? All right, here's the formula. The formula can be viewed in two ways. I like to put my first term out front when it's a fraction, like you're going to look at one down low. Because if it's a fraction, I want to make sure I know what number's in the numerator and what number's in the denominator. If it's a nice whole number, I usually just stick the whole number on top. Like if it was 2, I put it right there. So they're both the same formula, okay? And the formula is this. First term times 1 minus your r raised to how many terms you're doing, all over 1 minus r. Please, can I get your attention right here? This negative is not part of the r raised to the n. The negative is a minus sign in the formula. Now, if your r is -2, then yes, -2 is raised to the n. So that matters, you guys, because if a negative is raised to an n and it's even, it's going to turn out positive. If it's raised to an n that's odd, it's going to turn out negative. It does matter that you focus on realizing that minus sign is not part of the n. Sound good to everybody? Okay. All right. The formula looks more daunting, and that's just how it is, okay? It looks a little more, I don't really have easier way for you to memorize it. All right. If I ever ask you to find the sum of a sequence and I don't give you an ending term and I leave it in terms of n, then you can leave it in terms of n. But we're going to do one where we actually do give you how many more we want you to add. So we're going to just do one in general, and then we're going to do one where I actually gave you the number of n, okay? All right, let's try it. The sum of my sequence up to n, we don't know. Let's go ahead and send, so at first you want to double check things are geometric, and it looks like I'm timesing by 2. Timesing by 2, that right there tells me it is geometric, right? So I make note somewhere that my r is 2. I could have also looked at my nth term and saw that my r was 2. Good so far? Awesome. Jump up to the formula. What's my first term? 2. So I'll usually put the 2 on top when it's a nice whole number. Okay? All right, what do we need to know next for the formula? What goes in next?
The r?
The r does, and it's 2 to the n, and then just 1 minus 2 on the bottom. There is no exponent on it. And then we're going to leave it once we clean it up. We're going to take this is like technically over a -1, and I will always put this number and this number over each other. Does that make sense to everybody? I'll always take care of that mathematically. So technically the rule is -2, 1 minus 2 to the n. So I have kind of cleaned it up so that I now could find the sum of any n terms, okay? That's if I left it generic. If I gave it to you this way, we want to find the sum. What is this one communicating? It's asking me to find the sum of how many terms? In summation notation here. 5 terms. Good. Now, I'm going to show you, I want to compare writing out the sum, and I also want to just compare it to the formula. I chose to go really small number of terms so we could do it by hand and with the formula and compare. Okay? So, if I plug in a 1, that's 2 to the 1, plus plug in a 2, 2 to the 2, plus plug in a 3, 2 to the 3, 2 to the 4. Where do I stop?
2 to the 5. 2
to the 5. There is my series written out. Now mathematically, let's hurry and find the answer so we can compare it when we actually try this formula-wise, okay? So does anybody mind plugging this into their calculator and telling me what the sum of their series was? So this is us writing out the sum this way or this way would have been fine, but will you guys just give me the answer to that sum real quick?
61.
Yes, 2, right?
62. Oh, okay.
Yeah, right? Oh, I wrote 1. I don't know why I'm doing that. Yes, you were right, Ty, based on my mistake. 2 plus 4 plus 8, okay? So 62, okay? Let's see if us doing the formula gives us 62. So we are going to find the sum of this same sequence we just did up here, but for just 5 terms, okay? First term we said was 2, 1 minus r, but how many terms again? We're adding how many? 5. Good. So let's do the math. 2 is over a -1, and this is 1 minus, what's 2 to the 5th? 32. Yep. So this ends up being -2 times a -31, which is what? Positive 62. So we just confirmed the formula works out. And if I ask you to find 150 terms, you don't want to have to write it out like this. You want to know how to use this formula. Okay? Because I don't want to sit there and add more than a few, to be honest. Okay? I don't want you to be scared off with maybe an uglier, looking sequence. I think we actually went away from making you guys write these rules, but let's just do one for practice and then move on, okay? How would you guys write this in summation notation? How would I write this? Can you guys pick out what the rule is? Find the sum of the sequence from 1 to what? We stopped at?
3.
Just n?
Oh,
Because
n.
we didn't tell you how many terms. Can anybody come up with the rule of the sequence? Can anybody come up with that this looks like I'm doing what to my numerators? So this is my first term, this is my second term. What do you notice that they compare to?
The exponent is plus 1.
It's just n.
Oh, n.
Because I'm on my first term, I'm on my second term. And then the bottom is staying. So there's my rule. 3k over 9. There's my rule. And that's how you guys would write this in summation notation. And if I said to you, hey, find the sum of the sequence up to like maybe 7 terms, then we would take the time to plug into our formula, find our first term. What's our first term? We already have it. It's what?
3 over 9.
3 over 9. What's our r? Can you tell what your r is? What do we times by every time?
3.
Looks like just 3. And when you guys find out all those details, you can plug in your formula. Okay? So when you guys are asked to, essentially, here's your checklist that your brains need to go through, and then I'll start giving you some hints for your homework. Your checklist is going to be this, okay? Always check if things are arithmetic or geometric, unless we tell you, okay? Sometimes you just straight up need to read instructions, because we'll say, find the sum of the arithmetic series. But if we don't, and we say, hey, find the sum of the series, you may have to calculate if it's arithmetic or geometric. So for arithmetic ones that turn out arithmetic, find n. Find the first term, find the last term. If you don't have the first and last term, you may have to use your explicit formula to find different missing parts, okay? Even n. You may have to find n and plug in your first and your last term and the common difference. So you sometimes have to be creative and use that for whatever part's missing. Are you guys able to find the sum of an arithmetic series and sequence using our new formula we just went over, right? That's our checklist for arithmetic. If, after testing if it's arithmetic or geometric, you guys find out it's geometric, you're going to take the time to make sure you know at least how many terms you're adding and what r is. That's all you needed for the geometric formula, really. Or sometimes, so what you need there. So just a quick little reminder, we already know the explicit formula for geometrics. We know that the first term times your ratio raised to the n minus 1 is our formula. And if we ask you to do a sum, then you guys, all you need is first term, and then what your ratio is, and then for sure how many terms you're doing. So if you don't know how many terms, you may have to use logs to solve and find how many terms there are, okay? What if we don't know n for a sequence? Let's actually give you a hint, okay? And then I want to give you word problem hints. So here's my hint for maybe your number 13 and 14, okay? Let's go to 13. 13 is right back to being a 1 plus 2 plus 3, ... And typically, if we weren't doing this easy of a sequence, you guys wouldn't know what term this is. So let's play dumb. We know what term this is because the sequence is easy.
Yeah.
I want you guys to find the sum. So when you go to find the sum, I don't know how many terms there are. So my unknown, I have to kind of leave that blank for a second. But I do know my first term, and I do know my last term. So let's just play down that we don't know that this is 100 terms. What would I do? What did we do when we didn't know something? Like what did we do when we didn't know the last term? We plugged it into what formula? First off, is this arithmetic or geometric? It's arithmetic, so that's why I chose that formula. What do I do if I am missing n, a sub 1, or a sub n? What do I do? I use this formula. Okay? So let's use that formula when we're stuck on problems like this. So we have to go to do a little side thought here. Do I know my nth term? What do I know from that formula? Do I know my nth term? Let's write the formula here. A sub n, first term, my common difference, n minus 1 times. Do I know my nth term? What's my nth term of this sequence? Is this 13 still?
Yeah.
Okay. What's my nth term of this sequence? What's my last term? 100. I'm going to say a sub n for now, okay? Do I know my first term?
Yes.
Go ahead.
1.
Good. Do I know my common difference?
1.
Good. What don't I know?
N minus 1.
Technically, how many terms there are. Can I solve for n since it's my only unknown? Yep. We would minus a 1 over. And normally we would do what with this number out front here?
Divided.
We would divide it. Dividing by a 1 doesn't do anything to us though. And then you guys should get nice whole numbers when you're talking about the number of terms. So you screwed up if you're not. But what would I do now?
Plus 1.
Add a 1. And this confirms that, oh, I'm just adding my first 100 terms, which this one was obvious, but is 14 obvious? No. Is 14 as obvious?
No.
Not as obvious, right? So you do this on 14 as well. But now I know that I'm adding my first 100 terms, and we already did this because this was Gauss's problem, okay? So we knew how to do this because Gauss was brilliant. And we found out that it was like 50-50. So when you guys don't know n, go and find it. So on my hints for you is to find n. If you don't know n, go find it. Plug it into your nth term formula. Does everybody feel confident on 14? You can try it. Those are usually the ones that hang up my students the most. Okay, let's look at your word problems and then we should be good to go. Okay? When you guys are in doubt, if you don't know if it's arithmetic or geometric, start writing things out in terms just to see if what's kind of changing. Okay? So, for instance, I'm going to not do too much of 15, 16. But someone read 15, 16 story really fast, just to stop hearing my voice. Please? Who doesn't mind reading it for me? Anybody? Come on. Kirsten, you mind?
Yeah.
Read it for me, go ahead.
With the hard spiritual job, you how you will be paid by your employer. You agreed to be paid $50 for the first day, over 52 for the second day, and an additional $2 for each day until 14 days have passed.
Okay, until 14 days have passed. Okay, and then they'll probably stick for there. But, so I want you guys to, when you're stuck, write out your sequence. First week I'll be paid this. Second week I'll be paid this. Third week I'll be paid this. It is going to cap at your A sub 14 because we aren't going to go much beyond that, so it does end. Does that make sense? So that's how I organize it. Then, when we read this, we got to know what they're asking. Let's ask if they're finding a specific term on 15, and then if they're asking for a sum on either of them, okay? So on 15, how much will you be paid for working on day 5 and on day 12? Is that a sum or is that a specific term? It is. So like those ones, we're finding A sub 5 or A sub 12. Well, how is 16 different? Or someone reads 16's instruction. Ethan, will you read 16's instruction?
How much will you be paid
Total. What does that mean? It didn't say, how much are you paid on day 14?
No, that says 2 weeks, but it's still 14 days.
But what's different?
It's asking for the total amount.
What would I do?
So it'll be 2,000.
The sum formula?
Yeah.
Yes? It would be the sum now. So the first question was asking for what am I paid on day 5 or what am I paid on day 12, but what's this question asking? How much were you paid total? Does that make sense to everybody? I'm going to make you guys do all the work on that. Let's check another word problem. Don't keep working for a second. Let's look at 17 and 18. When an object is in free fall and air resistance is ignored, it falls 16 feet in the first second, 48 feet during the next one, and so forth. Okay? So, and then 80, and so it's during that second. Okay? So again, on problems like this, I write out the sequence to see if I can organize my thoughts. So the sequence would be, and that's the falling, because it falls, then it's going to have to bounce back up, right? And then it falls, and it's going to bounce back up. Oh no, sorry, it's just falling. So as something increases because of gravity, it fell this far, but then as gravity increases, it's falling a little bit further, right? Without, assuming no air resistance, okay? So let's go ahead and write that out. That's 16, comma, 48, comma, 80. What's this one doing? Did it times? That one looks like it just added, that it just picked up an extra 16 seconds per second every single second. Do you guys notice that? So did you guys notice that my common, not 6, it's 32. So it's adding a 32. It's adding a 32. Is everybody with me on that? Okay. So with that being said, what's it asking? How many feet did it fall during the 7th second or during the 10th second? Is that a sum or is that a term? That's a term, right? So when they use the word during, they're asking for a term. How does it change on the next question when they say, how many total feet would the object have fallen in 10 seconds? What can you do though? Yeah, you knew it fell this far, then this far, then this far. So if you go all the way up to 10, we can find the sum of those 10 seconds. So essentially, it's making you guys decide what's being asked. Is it asking me for a term or is it asking me for a sum? Okay. My 19 and 20, I feel like a couple people, let me answer the slide for these next hints. Okay. I wanted to have you working right now, but I hope these hints really do make you feel confident. Okay. So 19 and 20, would somebody read that word problem for me? Just to speed up the process. Takes time.
You are investigating 2 employment opportunities. Company A offers $33,000 the first year. During the next 4 years, salary is guaranteed to increase by 7% during the year. Company B offers $35,000 the first year with guaranteeing a minimum increase of 4%.
Okay. So if this one started at 33,000 and I am supposed to go up by what percent?
7%.
7%. I'm not timesing by 0.07 because that would make that number go down. What am I actually timesing by to get to my next year's salary? How do I find what that is? It's actually 100 plus the 07. So it's technically 107% because you had to increase its original by 7%. So technically my R, in order for me to go up, has to be by something over 1. So technically your R is 1.07 when you guys are putting together your work there. Now it asks you what you made in a specific year. So like what I made during my year 5, But on number 19, 19 asks what?
How much will you pay during 5 years?
Over 5 years, right? So that's a sum over the 5 years. Does that make sense to everybody? And this is going to change on the other one. So what's your rate if that one increased by 4%? You started with more, but it increased 4%. And what is that one? What's your R? 1.04. Does that sound good to everybody if I let you kind of suffer through that? Okay. The last hint I have for you is on 21 and 22. Who'd have thought that series and sequences are identical to like these functions and these real world ones? I think they're really interesting. All right, this one is, the other one was just an object falling from a really high distance, but this one is talking about an object that hits the ground, bounces back up, hits the ground, bounces back up, hits the ground. What happens because of gravity when I do that? I wish I would have brought a bouncy ball. But I drop it and it hits the ground. What happens every bounce? It doesn't quite make it to where it did. It does decrease over time. So when we read this, it says the height of a ball bounces is less than the height of the previous bounce due to friction. Suppose a ball is thrown in the air at a height of 4 feet and then rebounds always 78%. There is a trick question on part B that some of you might be confused about, but it says what height will the ball reach at the 6th bounce, meaning how high did it go? So what's kind of tricky about this is the original one, we're dropping this much, but when it bounces back up, I'm technically adding that and this. But what did the first one not include? Both what? Both up and down. So you have taken into consideration taking that off when you add stuff together. So on 22, make sure on your sum, once you guys find it, for whatever n is, make sure you guys subtract that initial, okay? However, let's talk about this. So the ball dropped, and what was the first distance when it dropped? 4 feet? So 4 feet. It's now going to come up. And so what do I do to find that next term? I'm timesing by what? 0.78. We have decided that 0.78 is our R, because that's what they said. Okay? You guys now have enough information on 21 to find what they asked. On 21 it says, what height will the ball reach on the 6th bounce? Okay, so you guys can plug in for n. We're asking for the height though, so you get to say plug in a sub 6. But on part 22, it says, how many total feet will the ball have traveled up and down when it hits the ground for the 8th time? Well, this first drop, I can go 2, 3. I essentially need to pretend that this never happened, right? So you got to be really careful to take that off, because it was just started here and here. Cool? Okay, those are my hints.